Solving linear equations with multiple steps. So the goal is to isolate the variable term on one side of the equation and then anything else on the other side, which is usually constant terms because we only have one variable in our equations. So if there's any like terms on one side, combine them. Any like terms on the other side, combine them. Now we look at our equation and we want to get the variables together. And we do this by adding or subtracting the same variable expression from both sides. One of the ways to think about this, and there's a couple of interesting apps that do this, think of X as like a bag with an unknown amount in it. And then we have like little number cubes that all weigh the same. And then inside the bag is some unknown number. And I got a whole bunch of copies of this bag maybe. And I need to figure out what to do to preserve the balance. That's the same idea we're doing. It can get a little weird with the negatives, but you can do it. All right. Multiply or divide both sides of the equation by a number required to make the coefficient of the variable 1. So get the variable by itself. Whatever you do to one side, you must do to the other. If we choose to multiply both sides by a number, but there's addition and subtraction, we need to distribute. Some problems, like if you glance at 15 there, we're going to have to distribute before we do anything else to that problem. Can't deal with parentheses inside the problem, not easily. All right, so let's start it out with 11. So I'm just going to draw that in to reinforce. There's my in the middle for my two sides. So 2 times x minus 7 is equal to 19. So I have a 2 I want to cancel out, and I have a minus 7 I want to cancel out. The 2 is attached by multiplication. The 7 is being attached by subtraction. Getting rid of the coefficient, the multiplying number, we usually do last, because getting rid of that means turning it into a fraction. And most people avoid fractions till the very end. So before we deal with canceling out the multiplication, we need to get rid of the other thing. So the opposite of subtracting 7 will be adding 7. And then the same thing on the other side. So I've added 7 blocks to both sides. On the left side, negative blocks and positive blocks cancel each other out. You can actually think of the negative as like a balloon, a negative weight, because it counteracts a down weight. I know, and some of you guys are like, now you're just taking it too far. I know, but that is the way it works. Then 19 plus 7 is 26. Ooh, card number. Now we just have 2 x's that are equal to 26. Well, if I just have both sides, I've got like 2 x bags that have the same number of cubes inside. And on the other side, I have 26 cubes. Well, if I cut them both in half and pull the halves off, I should still have equal sides because I'm doing the same thing to both sides, having both sides. So when I do that, it turns out that I can very nicely see that one unknown bag has split 26 into 2, and we get 13 little cubes. So for some people, having that like equation, metaphor, application, example, you can literally do this with manipulatives and like add the same thing to both sides, subtract the same thing from both sides, double both sides, have both sides. So for some people, thinking about that is beneficial because it gives you something more concrete to hold on to for the equations. So it's the only reason I'm kind of extending the crazy example is for those of you that it may be beneficial. If you guys are already comfy with your equations, I'm just babbling, ignore, it's okay. So now negatives everywhere. Why? Because. So negative 5 smushed onto m, and then minus 13 is equal to, is the same as negative 28. Again, the -5 is smushed onto the m, so that is attached by multiplication. So that is not subtracting 5, that is just a -5. Before I deal with that -5, I need to deal with this 13. So instead of subtracting 13 or to cancel it out, I'm going to add 13 to both sides. So -5 times m is all that is left on the left side. And then -28 plus 13. Positive 13 will cancel out 13 of the negatives, leaving 15 of the negatives. And now to cancel out the number -5 times m, we are going to use the opposite division and divide both sides by -5. So our crazy variable m here, -15 divided by -5, is +3. So if I plug 3 into this equation and work it out, it will balance. It will be the same on both sides. That is the value that makes that statement true. All right. Now this one, they gave us a fraction. It's only one fraction though, and it's on the variable. So we could leave that till the end, or we could do that crazy other step I did where we would multiply both sides by 2. If we do that on the left though, we're going to have some distribution. Most people don't like that, so I'm going to hold off on that. Instead, I'll focus on the 11 first. So the undo operation would be subtracting 11 from both sides. So we are left with just n over 2. And over here, 3 minus 11 gets to -8. Now, dividing by 2, the opposite operation, the undo, is multiplying by 2. Cancels out there, so we have just the n left. -8 times 2 is still negative, but it is now -16. I copied the other problems over here in case I needed more room. Just if you were wondering why those were over there. All right. So, moving right along. Let's kick it up a notch. So now I've got like terms on the left side and like terms on the right side. So before I worry about adding and subtracting, moving stuff, doing the same thing to both sides, first, I'm just going to ignore the right side. I'm going to focus on the left side. That's -7 minus 43x plus 44x. What can I do so this is not so complicated? So I've got two x terms. Those are like. So I've got -43x's plus 44x's. Well, those negative x's will cancel almost all of the positive x's. So -43 plus 44 is actually 1. A positive 1x. So I'm just changing those out for something I know is equivalent. On the other side, 19 minus 3. I pop those 3 off and we're left with 16. Now I wrote the 1x to be like very firm about why it is, what happened, but we don't actually have to write 1 in front of the x because if we don't write it, it's assumed to be there. 1 times x is always x. So this is really just x. And now I just need to get rid of this -7. And in this case, the -7 is added to the 1x. So to cancel adding -7, we could subtract -7, but again, minus negative is really the same as adding. And we end up with 16 plus 7 is 23. All right. Got one more in this video, the one that we start with distribution. Now it can get hairier than this, but we're not often going to do hairier than this in this class, I believe. I could be wrong. So first things first, no parentheses. Those need to go bye-bye. So 2 times the whole thing is the same as 2 times each thing. 2 times x is 2x's. 2 and then minus 2 times 5 is 10. And then I recopy everything else. So I just changed out the before distribution to what the after distribution would be. All right, parentheses are gone. Now I check for like terms. And since there's 3 terms on the left side, there better be some like ones in there. And we look, I have 2x's minus x. And then I have just minus 10. So that minus 10, we're going to have in the next line and the 8. But the 2x's minus x. 2x's minus x is not 2. This is 2x's minus, and if it helps, write the 1 back in. 2x's minus 1x leaves us with 1x. So I have 1x minus 10 is the same as 8. So now I want to undo minusing 10, so I will add 10. 1 times x is just x. And 8 plus 10 is 18. All right. So, not too bad. Now you take a gander. These are just going to kick it up a notch. I'll throw these into the last video.